Welcome back. Today we'll be discussing the resizable implementation of a stack. If you look carefully on screen, we have a type-defined structure by the name of stack. Our type-defined structure has three members. The three members are data, top, and size. Data is a char pointer which points to an array of characters. Since our implementation will be storing letters of the English alphabet, it makes sense to have a char pointer. After that, we have top, which maintains an index within the array, and we have size, which maintains the current size of the array, which is basically the stack. The reason why we have a size variable is that over the lifetime of the stack will grow or shrink, or better yet, the stack will resize, and we need to maintain the current size of the stack. Now, we have some stack operations. Stack operations are basically the functions that can operate on the stack. The first function we have is initialize stack. Initialize stack is pretty straightforward and it initializes the stack. So, if we successfully initialize a stack, we return true, otherwise we return false. A false return means that the stack was not successfully initialized, so that means we cannot go any further within the program. Now, we have isStackEmpty. isStackEmpty is pretty straightforward as well. It checks whether the stack is empty. So if the stack is empty, we return true, else we return false. After that, we have push. Push pushes a character onto the top of the stack. Now, if the push operation was successful, we return a true variable, else we return false. We have pop, which pops a character from the stack and returns nothing. We have peek, which returns a pointer to the top of the stack, else peek will return a null pointer if the stack is empty. After that, we have clear stack, which returns the memory that was allocated for the stack. So clear stack is really our cleanup function. Now, after that, we have resize stack, which resizes the stack. Now, resize stack returns a true if the resize operation was successful. That means if we manage to shrink or grow the array. If we failed in shrinking or growing the array, then we return false. Now, continuing along, the first thing we'll do is to define our C file stat.c. The first thing we'll insert in our C file is to include our header file stat.h. Then after that, we'll include the standard input output library header file, and then we include the standard library header file. So, the first function I'll be tackling is initialize stack. Initialize stack is pretty straightforward. It takes one parameter, which is the stack, to be initialized. So the first thing I'll do is to write the return statement. I do this because sometimes I forget to write return statements. It's not mandatory to do it, but sometimes I do it because it helps me to prevent errors. So, as you can see on screen, we'll be testing if the stack is equal to null. Some programmers may pass a null pointer, which is unacceptable. So we test if the stack is equal to null to prevent a null pointer error. So if the stack is equal to null, we can return, and we never use that pointer, which will never, result in a null pointer error. Now, the next thing we'll do is define the size of the array. So we'll start at a power of 2. Now we'll allocate memory for the array using calloc. Now, every time you allocate memory, you should test if the memory was successfully allocated. So if the memory was successfully allocated, then calloc will not return a null value. So if a null value is returned, that means the memory was unsuccessfully allocated. That means color did not allocate any memory for that variable. So if any memory was not successfully allocated, then we can return from the function because it doesn't make sense to go any further. So as you can see, I'm initializing stack top to -1. This mimics the video that I did on the demonstration of the array implementation of the stack. It's pretty much the same thing. So I'll put a little description of what the function does above it. I will not be doing this for every function. You'll see me do it for probably 2 more functions after this, and then I will not be doing it anymore. But at the end of the video, I'll be putting the descriptions above the function. This code will be located on GitHub, so you can check my GitHub for this code, and if there's any suggestions or improvement, please let me know in the comments, etc. So the next function that we'll be doing is stack empty. Stack empty is pretty straightforward. It takes one parameter, which is a stack, to check if the stack is empty. So we're going to do that same test to test if someone passed a null value, which is pretty standard. So after this, I'll not be explaining that test anymore. So to test if the stack is empty, we need to test if stack top is equal to -1. If stack top is equal to -1, then the stack is empty. Else, the stack is not empty. And basically, guys, that's it for stack empty. So the next thing after this is push. Now push takes 2 parameters, or has 2 parameters, which is a stack that will push the character onto, and then we'll have the character that we like to push. So we'll be doing our testing if the stack equals null that we did in the 2 previous functions. So what we're doing here is testing if the stack is full. So if the stack is full, then we'll perform the resize operation before inserting within the stack. If the stack is not full, then we can just continue with our insertion. So as you can see on screen, I'm writing a little description of what that if statement tries to accomplish. Please note, guys, right there is an arrow. Right there, the function call right there is an error, but I'll come later to correct it. So if you type the incorrect thing, no problem, but I'll come later to correct it. And by the end of the video, you'll get all working code. So pop is very straightforward as well. It takes a stack where it pop a character from, and it takes a pointer to store that character within. So we're doing the same thing. We're testing if stack is equal to null, and also we test if somebody passed a null character for letter. Not a null character, but a null pointer for letter. So you can see if the stack size reaches below a certain point, we shrink the stack, and we shrink the stack by a quarter every time. In the push function, as you can see, we grew the stack or doubled it every time we needed to grow. Every time we needed to grow the stack, we doubled it. As you can see, I just realized my mistake and I just corrected it. Now we're on to peak. Peak is pretty straightforward as well. It takes one parameter, which is the stack. So we'll be returning the stack top. We'll do our check to check if a null value is passed for stack. So we'll check if the stack is empty. If the stack is empty, we'll return null. If not, we'll return a pointer to the stack top. So we'll do a little bit of pointer arithmetic that a lot of people hate. But that's it, folks. That's it right there. That's it for peak. It's a pretty straightforward function. So we'll do resize stack now, which is a pretty straightforward function as well. So resize stack takes two parameters, the stack to resize and the new size of the stack. So we'll allocate our new array for the stack right here, which is data. We'll test it to memory successfully allocated like we did in initialize stack. Now we'll copy over all of the old items from start data to the new array. Right, there is an error, guys, but you'll see me coming back to correct that error later down in the video. And then we'll return the memory that was allocated for the old array. And that's it for resize stack, folks. It isn't anything complicated. Sorry about that. It should be clear stack. Sorry about that, guys. Sometimes that happens to me when I'm typing. Clear stack is pretty straightforward as well. It just cleans up the stack for us, returns all the memory that we allocated. So we'll add that little definition of what the function does above each and every function now. So I'll skip the video up and you guys can watch me debug the program from all the errors that are in it, listening to some nice music, and at the end you'll see the program working. So thank you guys, thank you for watching, and hopefully you learned something new and interesting today. Hopefully I could impart some knowledge. Thank you guys, and this is quite fun sharing my knowledge with you.
physical.